Well, good afternoon, viewers. Today we have a 2016 Tacoma, and there's a problem with the driver's heated seat. We gotta move the seat back. Manual seats. Where's the heated seat? And the blind spot monitor. Well, there's the heated seat switch. Well, the indicator comes on. Let's turn them both on and look at it with a thermal camera. He says that the indicator comes on, but the seat doesn't warm up. I'm not sure if that's both parts of the seat, the cushion or the back, but we'll look at it with the camera after a while and then we'll scan it for codes. Maybe we'll scan it for codes while we're waiting for the seat to warm up. Well, this is a previous vehicle I've worked on, but not for this. So we're going to do a network scan of all the controllers. I've got it running, I'm sure that's okay. See if there's any codes related to the seat or the blind spot detection system. I'm not sure exactly what's going on with the blind spot detection system. I'll have to get a better description from him. Lost communication with the accessory gateway. Light sensor malfunction. Lost communication with accessory gateway. Power window switch or passenger side door malfunction. These are all history codes. This lost communication is a current code. Lost communication with blind spot monitor master module. Compressor lock. Well, that's a history code for, I changed the AC compressor clutch, or drive plate actually, because it has broken. Maybe we didn't clear that code. Lost communication with navigation. Lost communication with HMI, I believe to be human machine interface. And rear sensor communication, intuitive parking assist history code. Well, let's do a network code clear. I've got a record of all these codes. And wants me to turn the key on, engine off. I'm going to take a look at the seat with the thermal camera. So we can see the passenger seat is heated up with the thermal camera quite nicely, but the driver's side, it's all the same color. Getting a glare off the camera, but it's at ambient temperature of 70 degrees. So both the back cushion and the seat cushion are not working. Like if you look over on the passenger side, it's about 86 degrees, and you can see the seat cushion and the back cushion are heated up. So I think first and foremost we'll check for broken wires under the seat, especially if the customer moves the seat a lot. So I looked under the driver's seat and I can't see any broken wires. I'm going to have to get a wiring diagram to look at what wires are the feed wires to the seat heater. But after clearing the codes and going into the blind spot detection system, I got a U0232, lost communication with blind spot monitor slave module. So that's probably where his blind spot detection system isn't working. And I'm not sure what a slave module is, if it's one of the sensors in the back bumper or tail light or what it is. But we'll investigate that. And we're going to look at wiring diagrams now. So we're looking at some electrical diagrams for the seat heater. It's powered up by one main relay that's controlled by ignition power from 7.5 amp fuse. That relay's got to be good, and the 20 amp seat heater fuse has to be good because that powers up the right side. So from that, it goes off on this L wire, And note 1 and note 2 is depending on when it was built. So that goes off on this side. So there is the seat cushion on the driver's side left hand. So I don't know what these letters represent. B, is that battery? Yeah, that must be battery. I found this BAE connector under the dash. So this blue wire is battery power. The E wire is ground. E for earth, I would imagine, B for battery. But then TH, E, and B, and different color wires depending on when it was built. That's the option 1 and option 2. This one's option 1 based on the build date. And it appears that the seat heater is controlled. So there's the passenger side one. 1, 2, 3, 4, 5 wires. Driver's side one has 1, 2, 3, 4, 5 wires. Wonder where this B wire goes. And it goes to the AC amplifier, the heater controls. Oh boy. Well, it doesn't show me which wires are the seat element itself, unless we start experimenting with the working side. I'm going to check to see if there's any troublemaker charts related to this, because there's no codes in the AC control system. And I took a brief look at data in there, but I didn't see anything related to the seat heaters. I found this BA3 connector under the seat. It's a 6-wire connector. It was plugged in. S40, S41. No, that's the connector I unplugged, S40. BA3 is a 9-wire connector. Maybe it was that. BA3. Unless it's not showing the connector on the seat itself. I don't see any broken wires under there, and I unplugged this connector going to the seat, and the seat switch doesn't work, or the heated seat switch doesn't respond at all then. I'm going to see if I can find a theory of operation in the instructions. So I did a keyword search for heated seat, and there appears to be a TSB, seat heater inoperative. Let's see what that suggests. Some 16 to 18 model year Tacoma may exhibit a condition where the left-hand or right-hand seat heater is inoperative. Follow the repair procedure in this bulletin to address this condition. Before the production change effective VINs shown below. Interesting. This repair is covered under the basic Toyota warranty. The warranty is in effect for 36,000 miles, whichever, 50,000 kilometers. Is the seat heater assembly inoperative? Yes. Continue to step 2. Replace the seat heater assembly. Just like that. Seriously, just like that. Wow. So that means the seat cover cushion's got to come off. There's an airbag inside the seat. I hate when they do this kind of stuff. They don't tell you how it works. I'm going to see if I can find a theory of operation. So this bulletin applies to vehicles produced before the production change effective VINs shown below. The VIN number on this is 5 Thomas Frank Harold Zebra. and it's a 4-wheel drive, 5 Thomas Frank. So I would take it that H comes after D, but then 5 Thomas Sam. I don't think this applies to this bulletin. I don't know where the assembly plant TMMTX is. You got to be a Toyota tech to understand all this jargon. I'm going to look up the theory of operation of this thing. How's this for a description? A seat heater system is used depending on the specifications. A thermistor detects the temperature of the seat surface, and the seat heater control subassembly controls it. The design of the seat heater switch has been changed. The shape of the front seat back heater assembly and front seat cushion heater assembly have been changed. Here's a precaution. The type of ignition switch used in this model differs from depending on expressions listed. That's useful. Seat heater system. That's useful. Let's try this one. By operating the seat heater switch on the air conditioning control assembly, the temperature can be controlled within the range of 36 to 42 Celsius. The on-off status of the heater level of each seat heater is identified by the respective indicators provided in the air conditioning control assembly. The seat heaters of both seats are controlled by the seat heater control sub-assemblies. Still doesn't tell me how it works. That's the same description. See if they got any troubleshooting. No fault codes. Front right seat heater sensor circuit. So I didn't have any codes. I'm going to start this thing up and check it for codes again. So I imagine the codes would be in the AC control assembly. Now I did unplug a connector under the seat, and I may have generated a code. Current codes. Nothing current. History codes. Left front seat heater circuit. So that B14C1, I think I generated that by unplugging the connector. As I unplugged the connector under the seat and I tried the seat heater controls and they were dead. There was no response. Let's see if there's any data related to it. Ambient temperature, regulator pressure, electric heater count, electric heater active level. Is that it? Or is that a heater in the HVAC system? That's all we got for data. I'll try operating the heater controls. So I'm operating the heater controls and nothing's changing on there, so I don't think that's got anything to do with it now. Is the data missing from the snap-on scan tool, or is it a problem with the heater? A problem with the scanner, or a problem in the lack of controls here? So I cleared the history code out with it running. I'm going to see if there's any bidirectional tests. Doesn't look like it, just the AC clutch, heater active level, air mix pulse D. So unless the scan tool doesn't support it and it's available, or it's not available. I'm not sure. So here is the symptom-based diagnostics for driver's seat heater does not operate. It says when the seat heater switch on the air conditioning control assembly is operated, the air conditioning amplifier assembly receives a signal. The air conditioning amplifier assembly receives a signal and operates the front seat heater. So here's a simplified schematic of it. And as I said, this same fuse feeds the other side and it works, so that's got to be good. So B plus on the, we can confirm that, and we can confirm ground on pin 5 and power on pin 3. And the switch is LIN bust, as you can see. I'm sure the switch is fine. Connect the tech stream, which is Toyota scan tool. Turn ignition on, turn tech stream on, enter the diagnostic body air conditioning data list. Check the value by referring to the table. Front left seat heater temperature. Well, I don't have that data parameter. Where's the HVAC? Heating and air conditioning. Automatic HC. Data. It says there's a temp sensor in the seat, so I suppose if that temp sensor fails, it could indicate that it's warm already, but then I would think it wouldn't turn it on. Room temperature, ambient temperature, evaporator target temperature, ambient temperature, degrees Fahrenheit, evaporator fin temperature, coolant temperature, electric heater count, shift set temperature, foot defrost auto mode, foot defrost auto mode 2, refrigerant gas type, number of trouble codes. Nothing to do with that. I'm going to try another scanner. So I'm using my ThinkTool Pro Plus on here. We're going to go straight into the HVAC system. See if it's got some more data parameters. (2016) Toyota. 16-pin DLC. What the heck? 2019, 2017, 11, 2019, 9. (17-pin DLC, 17-pin Toyota, 22-pin DLC, set area. Let's try that. North America. Without smart key. With smart key. Okay. AC. Read data stream. Another thing Snap-on doesn't have is a keyword search for front left seat heater temperature, front right seat heater temperature, Snap-on for the fail. So they're both sitting at 66 degrees, so that's realistic. Let's select all. Well, it's the only two data parameters that we seem to be missing. Wait a second. Where's the seat heater? Read data stream. Okay. Oh, there's another page. Front left seat heater, front right seat heater, number of trouble codes. Page 3. So that's the only two data parameters that look like it was missing. Actuation tests. Definitely more actuator tests, but nothing to command the seat heater on. Special function. Customize settings. No, we're not doing any customization. Let's do a smart scan and see if there's any other codes related to the crash sensor or the blind spot detection sensor. Two codes in the BCM. I don't know what SMK is. That's probably blind spot monitoring system. That's the blind spot monitor slave. That's no communication. Let's see. Smart key, lost communication with accessory gateway. And lost communication with accessory gateway. Oh wait. Lost communication with blind spot monitor slave module. U0232. That's the same code we had on the Snap-on scan tool. Okay, let's have a look at this diagnostic flow chart. So both seats are not out of range temperature-wise. Normal condition. Display is okay. The display is as specified in the normal condition. 96 to 109. Well, that's with the seat on, front seat heater on. So I'm going to take it that it doesn't work. Measurement from, so that would mean it's not okay. Proceed to A. Disconnect S40 front seat heater assembly connector. Measure voltage and resistance according to the value. So S40 is one of those connectors. S40 pin 3. Ignition on, should be 12 volts. So between the V wire and the body ground should be 12 volts. Between the E wire and body ground below 1 ohm. Well, we'll qualify those two wires. If they're okay, inspect front heater cushion assembly. Remove the front seat heater cushion. Yeah, sure, just like that. Well, we're going to check powers and grounds, and if they're good, we're going to condemn the cushion. So I got a test light, 500 milliamp test light attached to pin 3, which is battery power, and pin 5, which is ground. It lights the test light, and I'm measuring the voltage on it loaded, and it's 13.5 volts with the engine running. So those two circuits are good. Let's see what the troublemaker chart suggests to do. So the troublemaker chart suggests to use a voltmeter on the B plus wire, and it should be 11 to 14 volts. I load tested it with a test light because I'm sure that seat heater draws a couple of amps, if not more. And the body ground wire, which is pin 5, it said to use an ohm meter to ground below 1 ohm, but I used it as a ground for my test light, and I got power and ground on both wires. So it says remove the front seat cushion assembly, C16 to 17, 18, whatever. Replace the seat cushion assembly heater. So I should have went with the TSB that said, if it doesn't work, replace the seat cushion heater. So I'm looking up the fault code, the U0232 for lost communication with the blind spot monitor module slave. And I see another TSB, imagine that. Let's see what this suggests. License plate lamp moisture and or blind spot monitor abnormal operation. Some 16-year Tacoma vehicles may exhibit one or more of the following conditions. Moisture in the license plate lamps, discolored license plate lamp, blind spot monitor system inoperative. Don't tell me they're using the license plate lamps. Contains two different diagnostic procedures and two different repair procedures. Refer to the procedure that best applied to the vehicle condition and the vehicle's rear bumper configuration. For license plate lamp moisture discoloration conditions, use diagnostic procedure A. For blind spot monitor system inoperative condition, use diagnostic procedure B. Okay. Blind. Both within applies to vehicles built for VINs. Here we go with the VIN number again. With blind spot monitor and no ultrasonic sensors, with blind spot monitor with ultrasonic sensors. How do I know what it's got? Oh, brother. Let me do some reading. So looking at the rear lights, we got the left tail light, but the right tail light, only the top half is alive. And then both license plate lights are working, and they're not discolored. Normally the blind spot detection monitors are in the tail light here, on the side of the tail light. I'm not sure if this is a conventional bulb in there. It kind of looks like it. Let's fix that at least, or attempt to. Well, I replaced the bulb. It's a 7443 bulb, and that restored the operation of the lower half of the tail light, but there's no wiring in there for a blind spot monitor. There's a backup light and these two tail lights, turn signals and brake lights. So we got to figure out where this blind spot monitor is. It says license plate lights, but I don't see any. They look normal. So looking under the back of this truck, I think there's a sensor right here. This is a parking aid sensor. These are parking aid sensors, but I think there's a sonar sensor or something in here. Shoots through the plastic of the bumper. There's one on each side. Now I'm not sure which one is slave A. So my take on this is, if I unplug that black connector and test that green wire in the connector going to the front of the truck, that's ignition power. I'm taking that the left blind spot sensor is the master and the right one is the slave, because it says to check for power there. But when I unplug it, then I lose communication with the master. So I don't see anything wrong with the wiring, so I'm going to call this blind spot sensor. I'm going to talk to a field service tech who works on these every day and see if it's common for them to fail. Man, those wires are tiny. So it has you checking for power at that black connector pin 4, and then it says to go to the blind spot, the right. It says left-hand blind spot monitor. Well, that's this connector there, and you can't get at it without disconnecting, taking trim off. You can't unplug that connector. Depending on the tool used to back probe the blind spot monitor connector, some rear bumper disassembly may be required. Yeah, no shit, Sherlock. But when I unplug that connector, I'm not sure which one that is, B12 or B13. No, it's on the previous page here. It's either BE1 or BE2, but it's a black connector. BE1, black connector. If I unplug that connector, then I lose communication with the master, which I take that to be the left-hand side. So one of the problems I'm having is identifying which one of the blind spot monitors is the master and which one's the slave. I'm taking it to be the left one being the master because it has the CAN in and out, whereas the right one only has the CAN in. So if you look at this diagram here, I really need to disconnect that right blind spot monitor and test the powers and grounds to it. So that's a combination meter. There's the blind spot monitor right side. So there's CAN pin 1 and pin 6. Ground on pin 10. And power on pin 8. Looks like 8. Whereas if we go to the other diagram here, the left blind spot monitor has 2 CAN lines coming in. So I'm going to raise it up again and try and get to that connector on the right blind spot monitor and do some testing there. So I tried for several minutes to get that connector released from the back side, but I couldn't. So I popped this plastic corner off. There are several push pins along the bottom and 2 inside here. And then you have to pry this cover up. And then there's 2 ears, retaining clips like this that hold the plastic on from the top. Now we got the connector accessed here. We should be able to unplug it and do some testing here. So ignition key on, clean battery charger on it, voltage at pin 5, it's 13.58. I've got the battery charger on it. And if I load test it with a test light, it lights the test light, as you can see. So the ground is the other pin we got to qualify. Let's look at see which terminal that is. So there's a test light connected between pin 5 and 6, I think they are. Five is ignition power. No, 5 and 10. The 2 end pins, the light green and the white and black. I got a 150 milliamp bulb on there, so the powers and grounds are good. So we're going to scope the CAN bus signals, which is pin 1 and 6. It must be at the other end of the connector. So that looks like good network activity on pin 6, and the other pin is the one below it. Should be a mirror image, and it is. So that pretty much confirms the sensor has failed. Now I'm going to look at what's involved, what's held in with 2 nuts. Well, that's not too bad. 3 nuts. 3 6mm nuts. One up top. We'll see what the price of this sensor is. So I deoxidized the pins and I reconnected it. Put some dielectric grease around the seal, but I still got the same code. So I'm going to disconnect it and see if it generates any other codes. It's easy to disconnect now that the connector is free of sand. Read fault codes. So we still got communication with the master, but we have no communication with the slave. So the right side is the slave on this one. According to my helper at Toyota, on the Tundras, it might be the other way around, where the right side is the master, but I can't confirm that. Like I said, in the service literature, they refer to them as left and right, but in the scan data, they refer to them master and slave. Why couldn't they just say left and right on the scan tool? But I guess that would make too much sense.